All right, for nitrogen, you've got a periodic table in front of you. What do we start off with? Always. 1s2, 2s2, 2p3. Guys, let's be with me. All right, so 2p3. Does anybody have a question about this one? All right, let's go to oxygen. What do you have for oxygen? 1s2.
2s2. 2p4.
Okay. Yes or no?
C.
All right, let's go to fluorine. 1s2.
2s2. 2p5.
And then the last one for neon, what do we have? 1s2. Okay. Do you see the pattern? All right, let me ask you some questions. What is the last configuration notation for bromine? I want to see if you really know what you're doing. What is the last configuration notation for bromine? So here's bromine. Its fourth energy level, P subshell, 1, 2, 3, 4, 5. Yes or no? Does that make sense? What is the last configuration notation for strontium? 5s2. Who does not understand that? Okay, Lucas, do you understand that every one of these are S1? Do you understand every one of these are S2? P1, P2, P3, P4, P5, P6. Then if this is strontium, fifth energy level, S subshell 1, 2, 5s. Does that make sense? Okay? All right. Now, I want you to do titanium. Actually, let me go easier than that. Do chlorine. Let's do chlorine. Do the complete electron configuration notation for chlorine. Write it down. Complete electron configuration notation for chlorine. All right, what do we have? 1s2. Okay, I hear 2 people. You're going to have to all do better than that, or we're going to be doing this all day long. Yes or no? Okay. All right, go to titanium. I want to see if you can follow the rules. Pay attention to your periodic table. Do titanium, pay attention to your periodic table. You wrote down what to do when you get to that area. Pay attention. Okay. Do you all know how to do a common reading? That means everybody's together, so you got to listen to everybody else, okay? All right, I'll start you off. 1s2.
2s2. 2p6. 3s2. 3p6. 4s2, 3d2.
Wow, much better. Not good enough though, but much better. But I'm really glad you got 3d2. That's what I was waiting for. I was waiting to see who messed that up, and I didn't hear anybody mess it up. Does that make sense? Now, I'll tell you, you did what I asked you to do, which is good. We're going to do a couple more to make sure you know how to do it, and then I'll tell you why it does what it does. What's funny to me is that none of you asked why. None of you said, why does it go to 3D? But maybe you don't care, and that's okay if you don't care. Don't be such a follower, though. No offense, but you should ask why. I will tell you why in a minute. No, and I will tell you why, but what I'm saying is in general, no offense to all of you, but quit being such a follower. That's part of the problem with bad advising at Western. You guys, do you understand some of your advisors are not good advisors? Quit being a follower. Look it up yourself. Be proactive, okay? I'm not saying just totally butt heads with everybody, but ask questions. You should have asked me earlier. Why does it do that? Thank you for asking the question. I'll answer your question in a minute. Let's do a couple more. Okay? And then I'll tell you the why. I want you to learn how to do the pattern, and then I'll tell you the why, okay? I want you to go down here to silver, AG. Do silver, AG. Katie, where's your periodic table? Your periodic table? Okay, good. Honey, let me tell you something. Quit copying it from, do this on here. Instead of copying it off of here, learn to use this. Learn to use this to do it, okay? Because you're not going to have, so this is S. Because you're not going to have all those on your test. You've got to be able to learn to do it off of here and take. So don't look at the pattern that we've already done. Do it off of here, okay?
Really, the duct tape itself, just put it on there and pinch it together and go through it. That would be good. The tape on it,
All right, kiddos, let's do it. All right, silver. What do we have for silver? You ready?
Yep. Should I start it?
Go ahead.
1s2,
2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d9.
Oh, your buddy, man, your harmonizer there. What's the problem, dude? 4D9. Good job, good job. Good job. Yes or no? We got it? All right, now then, we're going to go another one. Let's see if you really have it. What do you do with a calf at a rodeo? I've already told you all these funny, doofy jokes. What do you do with a calf at a rodeo? Europium. Europium, baby. Europium. 63, Europium. Do Europium. Mister, get off your phone over there. You were just on your phone. Yes.
I was not on my phone.
You were not? Okay, good deal. Good job. Thank you for watching. Europium. I was actually teasing you because I've been told AT&T was out, but I know it's not. So I didn't know if you knew that.
No,
Good job.
AT&T is in. It's Verizon.
Oh, it's-
AT&T is out. Verizon's still out.
Okay. Are you a Verizon customer?
No, I'm a Cricket customer.
No, I'm talking to him.
Oh.
I don't even know. I think Verizon.
That's why he can always use his phone. I'm teasing. Quit! Stop cursing in my class.
Sorry.
Come up with a smarter word than that.
She.
Shoot. Well, gosh, dog. Europium EU. Let's go. Pay attention to your numbers. Pay attention. Where do you go after 56?
Down 4F.
Down to 4F. Pay attention to that. After 56, you should have an arrow. Look at your periodic table. After 56, you go down to 4F. That's why I drew this arrow with the numbers. All right, we're going to have, are we ready or not? Nope. Okay, we're going to do the left side, my left only side of the room has to sing. Josh has been carrying all of you. So the left side of the room has to do it for europium. Okay, then the right side's going to do it. Then we're going to separate out to ladies and gentlemen. So be ready, there's going to be 4 more. Okay, so this is I've already taught this in 109. This is a very important day for me because very likely I will never teach again. And you are my last class to get to hear sing. So you have to do good, okay? Don't look at me that way. When you've been doing this for 8 years, and this is your most important class of the whole year, and it's being recorded for infamy. Okay? So you better make it good. You better make it good, okay? The internet, YouTube, is depending upon you, okay? Are we ready? This side of the room. Joe, you ready? Okay. All right. Are we ready? Yes. All right. 1S2.
2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, 4F6.
4F7. Very good. Very good. Let's count. Let's count. 4F, 1, 2, 3, 4, 5, 6, 7. Yes or no?
Yes.
Everybody with me? Yes or no? Talk to me on the left side of the room.
Yes.
All right. All right, let's be quick. Bismuth. If you got a lisp and people are bugging you, you say, that's not your bismuth. Ha ha. Okay, BI. BI. Everybody do BI. Bismuth. BI. 83. Bismuth. Right side of the room. Right side of the room. I need to hear all sopranos, altos, second bass, first bass, tenor. Okay? All right, are you ready, Bismuth? All right, 1S2.
2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, 4F14, 5D10, 6P3.
Very good, very good, very good, very good, very good. All right, now, if both sides of the room would do that well, people would be wondering what we're talking about in here. That's how I want to hear it, okay? Please, give me that pleasure. Come on. Come on. I'm going to make everybody do it again. Everybody together. I want to see you do Einsteinium. Let's give honor to Mr. Einstein here. Einsteinium, ES number 99. ES number 99. ES 99. I love you all. You're welcome. Thank you, Alfredo. This is a good, you all been fun. You've been a good class. You're fun. Honey, every day is an end. Don't you realize that? And every day is a beginning. Think about that. Think about, no, think about that. All right, are we ready? Guys, we're not guaranteed tomorrow. It could be the end. You know? Seriously. You should live every day like it's your last day. Do you not realize that? When I fuss at you all for being on your phone, that's why I do that. Do you not understand that? Today is the only day we have, this moment. If you're not realizing that, wake up. Okay? Willow, it's true, it's real. That's real. All right, are we ready? All right, come on. I want to hear you. Everybody, okay? All right, clean that throat out. Let's go. We got it all? Brandon, you ready? All right, we ready? 1S2.
2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2, 4D10, 5P6, 6S2, 4F14, 5D10, 6P6, 7S2, 5F11.
Very good, very good, very good, very good, very good. All right, real quickly, let's just do antimony. Girls, I'll have you do a shorter one because I really want to hear the girls. Antimony, SB. Antimony, SB. Quickly run through antimony. Write antimony down. If you guys have got this beyond a shadow of a doubt, you don't have to write it. You can just say it because we've done a lot and you've done great. You've humored me well. But if you're struggling writing it, then write it. Do antimony, SB. For the girls, this is girls only doing antimony. Girls only doing antimony. I just realized maybe I'm not supposed to say that. Is that proper for me to say girls only?
Yes, it's proper.
Okay. I was like, oh my gosh, am I going to be in trouble here? Okay. All right. If you identify as a female, is that proper? If you identify as a female, then it is female identifiers only. Okay? All right. 1s2.
2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p3.
Very good. Very good. All right, guys. You did a good job. You did a good job. Thank you all for humoring me on that. Now, the good news is you don't have to do that for every one of these. Isn't that great?
Yes, ma'am.
Those are long, weren't they? But it's fun. I love hearing you all do it. And thank you for humoring me. I'll listen to that when I get old and grayer, and it'll give me humor. So thank you all. Okay, so now we're going to do noble gas configuration notation, which is the abbreviated way to do this. Because what have you discovered? Every time you write these, what do we find happening? Are we filling everything up until the very end? Every time. We fill everything up until the very end. And so that's why we actually can use the previous noble gas and then continue. So let me tell you what abbreviated or noble gas configuration notation is. You use, or let me not say, let's say write. Write the symbol of previous noble gas in brackets, and that's what I'm talking about in brackets, then continue with configuration. So you write the symbol of the previous noble gas in brackets, and then you continue with the configuration. So let's just take, for instance, the europium. That was super long. Let's take europium and find europium on your periodic table. What number is that? 63. Who is the noble gas prior to that? Xenon. Very good. So you put xenon in brackets. You put the symbol for xenon in brackets. And then you go to europium. So what's next? Guys, come on. What's next? 6s2. And then what? 4f7. That's exactly right. Isn't that a lot faster?
Yes.
Yes. All right, let's do a couple more. Do silver. Do silver and let's do one you haven't done. How about, nope, not that one. How about polonium, PO, and cesium? So do europium, silver, polonium, and cesium. Do those. Okay, who is the previous noble gas for silver? So here is silver, and it would be krypton. Good. So we put krypton in brackets, and then proceed from there. So what comes after krypton? Good. So 5s2, and then what? 49. Good job.
Can you explain a little bit how you got krypton again?
How good, yep. So silver is right here. It's 47. The next noble gas would be xenon, but that's 54. That's after. So the previous is 36, which is xenon. Okay? So oftentimes what I'll do when they're this far on the right side is I'll go, that's the next one, go up one. Okay, but pay attention to the numbers. Pay attention to the numbers, okay? And I'm going to answer your question next, okay, on the why. All right, polonium. So polonium, what's the previous noble gas? Xenon. Good. And what comes after xenon?
6s2, 5d.
Up. What comes after 6s? 4f. Good job, Rance. 4f. How many? 4f 14, and then 6p 1 2 3 4. Good job. You can't forget going down to the F. Yes or no? All right, and then cesium. Cesium's super easy. What? Man, I did every one of these right in that same area, didn't I? Sorry. What's the previous noble gas? Xenon. Sorry about that. And then what do you have?
6s4.
So super easy. Yes. All right, you need to make a note of this in your notes. Pay attention and listen to me. On achieve homework. On achieve homework. Pay attention because they give you, Brandon, they give you the noble gas in brackets. They're giving you that. Don't write it again. You with me? So when you look at your achieve homework and it says do the noble gas configuration, if you pay attention, it says XE or KR or whatever, you just proceed from there. Don't do it again. Don't put it in brackets again. It's already there. That messes people up. So I'm telling you now, that's what's going on, okay? All right, now the question is, why? Why do we go down and come back up? Go down and come back up. Go down and come back up. Why do we do that? All right, there are two things that are affecting energy. There is the distance of the electron from the nucleus, yes? Energy, tell me energy. Energy, tell me close to the nucleus. Low energy or high energy? Low energy. Doesn't take much energy to be down here close to the nucleus, correct? As you get farther away, it takes more energy. So energy, we're dealing with low energy to high energy. So that's one aspect of energy. It takes this amount of energy depending upon what energy level you're in. But then the second avenue of energy is what are you doing? What are you doing in this space? You could be doing a sphere. You could be doing a figure 8. You could be doing the clover leaf. You could be doing F, which we can't even describe, yes? Which one's lowest energy? S. Highest energy? F. Okay, so two things are take energy. Two things are affecting energy. So electrons are like people. Generally speaking, they're lazy. They're going to do low energy first before they do higher energy jobs. So watch. You fill up first energy level, and what do? What shape? Come on, you got it. What do? Sphere. First energy level, and you do the sphere. Is that lowest energy level of all aspects? First energy level, S, is very low energy. Then you go a little farther out. Take a little more energy. So what are we going to start with first? S, and then we do P. Then we go to the third energy level, a little farther out. Takes a little more energy to be there. Again, we start doing what, though? S, then what? P. Now, look at your periodic table. After you do 3P, where does it say we go? 4S. So here's what literally is happening. It takes less energy to go farther away from the nucleus and do an easier path. It takes less energy to go to the fourth energy level and do the sphere than it does to stay in the third energy level and do the D shape. That is why it goes to the fourth energy level S subshell and then comes back down to do 3D. 3D takes more energy. It does lower energy first and then comes back and does higher energy. And then it goes out to 4P. Keep going. Where does it go after 4P? 5S, so I'm going farther away from the nucleus. And then again, it comes back closer to the nucleus to do a harder shape, which is 4D. Goes back out to 5P. Then where does it go? 6S. And then it comes way down here to 4 to do F, which means F takes a lot of energy. So it doesn't even do 4F until it's been all the way out here to do 6S. It's all about energy. Give you one other scenario. I don't have this at my house now, but at one time, there were 2 jobs that had to be done every morning at my house. One of go a little farther away to do an easier job, then they will stay closer to home. Maybe one day I will, but I'm a big asking why person, so I try to always do that with you guys. But in this case, just make sure you do it, whether you care why or not, okay? All right. The whole purpose of doing all of this has been to help you understand ions. And I love to teach you this, and I think it's fun, but a lot of teachers do not even teach electron configuration notation at the 100 or 105 and 109 and 116 level. I think it's important because I think it helps you understand ions. And so, actually I'm going to keep both pages up here. If we look at these elements that I've drawn, most of them can form ions. You already have been in lab and you've been taught how to look at a periodic table and say this entire column has what charge? Positive 1. This is what? Keep come on. Plus 2. You got to say plus or minus. So do it again. Plus 1. Silver. Zinc, cadmium, mercury. Aluminum. Nitride, phosphide. You with me? Okay, now, why? Why? Why do they have that charge? Why do they get that charge? They gain or lose electrons. Yes, that's correct. But why do they want to gain or lose electrons? Well, you're going past where I'm talking about right now. You're dealing with compounds. You're thinking of compound. I'm not talking about a compound. Let's go, why do they want to make a compound? Why do they want to make a compound? Why do you want to get married? Why do you want to marry another element? Why? Stability. makes a stable element? Who on the periodic table is stable? Noble gases. So why do elements form ions, which then in turn make them have to be bonded to somebody else? Because it helps them be more stable. Now, be with me. This is aha for some of you. What did you just tell me fluoride, chloride, bromide, iodide get a charge of when they become an ion? You told me this. What charge? -1, which means they've what? Gained 1 electron. Why did they gain an electron? So they would look like a noble gas. Does that make sense? Let me say that again. All of these want to look like the noble gases. How can they look like a noble gas? They can gain 1 electron. How can all of these look like a noble gas? Gain 2 electrons. And when they gain 2 electrons, what charge do they have? -2. What do all of these do? They gain 3 electrons. 1, 2, 3. And what do they look like now? A noble gas. What charge do they have after they've gained those 3 electrons? -3. And the whole purpose of doing that is to look like a noble gas. That's the whole purpose. Now go on this side. All of these, and forget hydrogen for a minute, these want to do what? What do all these want to do? They want to look like a noble gas. The only way to do that is to what? Lose. How many do they lose? 1. And if they lose 1, who do they look like? The noble gas. Does that make it more stable? Yes. Because we have now in all these noble gases what we call a full outer energy level, also called a full octet, also called stable. Why? Because what is our outer energy level? Let's just think about this for a minute. These are the energy levels, correct? Let me zoom up. These are the energy levels right over here on the left. These are all the energy levels over here on the left side. These are the energy levels. So what is the outer energy level for argon? What's the outer energy level for argon? Come on, I'm right here. Look at my finger. 3, yes? So argon has how many valence? I'm going to write all this down in a minute. Valence means outer energy levels. Outer energy level. How many electrons are in the third, which is the outer energy level for argon? 1, 2 are in S, yes? 3, 4, 5, 6, 7, 8. Because don't we say 3s2, 3p6? Aren't there 8 in 6 plus 2? Yes. Look at neon. How many are here? 6 are in what subshell? P. And how many are in S? 2. Is that 8? Yes. Now, krypton is a little tricky. But you know this, but don't get confused. What is the outer energy level for krypton? 4. 4. How many electrons are here? Well, 2 are in 4s. 3 is 3, guys. It's not outer, it's inner. 4 is outer. 1, 2, 3, 4, 5, 6. What's 6 plus 2? 8. Same thing happens for krypton, xenon, and radon. Do these D's or F, are they in the outer? No. No. And then we go back to, okay, who's going to lose electrons? We already said this a long time ago. Metals. Metals will lose. Non-metals will gain. And it makes sense why they'd gain. Aren't they already closer to being full? They don't want to lose. They're going to gain. Now, there are some elements that can do either or. Carbon, we don't deal with carbon as an ion at all in this class. In all actuality, carbon can lose or gain, but we don't deal with it as doing such. We typically say carbon will only share, but it can lose or gain because it's right in the middle. Our rules in this class are if it is to the left of the stair step, it will lose. If it is to the right of the stair step, it will gain. That's our rule, okay? So, aluminum. Aluminum has a charge always of what? +3. How does aluminum become +3? Just generally, it has to lose what? 3. Which 3 is it going to lose? Tell me which 3 aluminum is going to lose. It's going to lose how many out of S? 2. Is it going to lose these 2? And what else is it going to lose? 1 out of P. Does that make sense? It's going to lose the 3p electron and the 2 3s's. Is that making sense? Does this help you understand why ions are what they are? Do you see why we do all this? Then you're like, oh, that's why the ion becomes what it becomes. That's why it has the charge that it has. So then, even then, your memorization, when you've done +1, +2, then you know why it's +1, +2, +3, etc. Then you know why. Now, in order to become nitride, what does it have to do? It has to do what? Nitrogen to become nitride has to do what? Gain what? 3. Where does it gain them? What energy level? Energy level is a number. 2. What subshell? P. Yes? Does that make sense? All right, let's see if it makes sense. Draw the ion electron configuration notation for sulfide. Draw the ion electron configuration notation for sulfide. Now, this is after it has already become an ion. This is sulfide. Guys, we don't need an ion sheet. We don't need an ion sheet. It wants to look like a noble gas. It wants to look like a noble gas. Who is sulfide going to look like when it's sulfide? Is it going to look like the next noble gas? Does that make sense? It's going to look like the next noble gas. So find sulfur on your periodic table. Find sulfur on the periodic table. Who is sulfide going to look like? Right there. Then draw the electron configuration notation for who? Argon. All right, let me ask you some questions. Now listen to my question. How many normal electrons, does normal sulfur have? Normal sulfur has how many electrons? Just normal sulfur. Total normal sulfur. Total normal sulfur. How many electrons does it have? 16. Do you see this? Normal sulfur has 16 electrons. Yes or no? Okay. How many electrons does it have when it's an ion? 18. Why? It gained 2, yes? Who has 18 normally? So whose electron configuration notation are you really drawing? Argon. So you draw electron configuration notation. What do you have? 1s2, 2s2, come on, 2p6, 3p6. Yes or no? Are we understanding this? Talk to me. Not understanding it? Let's look back. Let's look back at the periodic table. Who does sulfur becomes an ion? I've told you right here it becomes an ion with a -2 charge, which means it's gained 2 electrons. Does that make sense? So if it had 16, 16 plus 2 is 18. Who has 18? So you draw argon. You draw argon. Does that make sense? So you should have 1s2, 2s2, 2p6, 3s2, 3p6 on your notes. All right? Draw the electron configuration notation for sodium ion. Sodium ion. I'm telling you it's +1 charge. You don't have to look it up. I'm telling you it's +1 charge. Now the question is, who does it look like when it is +1? What has happened to make it +1? What has happened to make it +1? Come on. It's lost an electron. How many electrons does it normally have? 11. So if it's lost one, how many do we have now? 10. Who has 10 electrons? Neon. So who are you really drawing? Neon. So 1s2, 2s2, 2p6. Is that correct? Does that make sense? Okay. Now, if it really makes sense, answer these questions. Who else looks like neon? And I'll do the easy one. Neon looks like neon. Okay, neon looks like neon. What other ions look like neon? Raise your hand if you know what other ions look like neon. Ryan, tell me. Magnesium +2. That's correct. Good job, Ryan. Magnesium +2 will look just like neon. Yes or no? Who else? Willow, who else looks like neon? Say it don't say it like you just said it. Oxide. Oxide will look like neon. Yes. Because oxide has what charge? -2. So oxide, so we've got magnesium looks like neon, magnesium ion looks like neon, sodium ion looks like neon, oxide ion looks like neon. Somebody else tell me another one. Aluminum. Good job. Aluminum ion looks like neon. I'm proud of you. That's good. Aluminum ion looks like neon. Why does aluminum ion look like neon? What charge does it have? +3. 1, 2, 3. Does that look like neon? Good job. So aluminum ion looks like neon. Who else? There's two more. Nitride. Nitride looks like neon. And then there's one more. Fluoride looks like neon. You got it. Does that make sense? Every one of those looks like neon. Every one of those looks like neon. Very good. Very good. Now, I want to see if you can, let me write something else down. Let's talk about valence electrons, and we're going to do both of these at the same time. We're going to talk about two different things here. I've already said this. I'm going to add to it here. Valence electrons are outer energy level electrons. Valence electrons are outer energy level electrons. Valence electrons play the most important role in forming compounds. They are either lost, shared, or it is the valence shell where electrons are added. We've already been working with valence electrons, but now I'm just going to straight up ask you number of electrons in the valence shell. I've already asked this to a certain degree, but I want to see if you can actually tell me from just random ones and see if you've gotten it. How many outer energy level electrons, or how many valence electrons, are in hydrogen? That one's a super easy one. One. Very good. How many electrons does hydrogen have at all? One. Where is that electron? First energy level, S shell, and is that the only energy level it has? So is it the outside? Yes. Now, something I haven't mentioned to you until right now is you understood, I think, most of you, when I went down through neon, argon, krypton, xenon, radon, and I said how many outer energy level electrons do each one of these have? We already said this. How many? 8. Where are they? 6 are in P and 2 are in S. Yes? So those all had 8. And they're noble gases and they have a full outer energy level. So are they happy? Everybody got that. Why is helium a noble gas? Because the valence shell is full. Perfect, Ryan. The valence shell is full. That's exactly right. Because what is the valence shell for helium? 1 is the energy level. How many electrons can the first energy level hold? 2 because of S. That's why. So helium doesn't have an octet, it has a duet. And that's all it needs because its outer energy level is full. Its valence shell is full. So now, why did I put helium over here when I drew it? To show it has 2 electrons in S, and is that full at that point? Yes. Now, how many valence electrons does sodium have? Valence, outer energy level electrons. 1. Why? Because of third energy level S subshell. How many are there? 1. And if you go before that, you were in the second energy level. What's the outer energy level for sodium? Outer energy level for sodium. Outer energy level for sodium. I'm pointing to it. 3. How many electrons are there? 1. How many outer energy level electrons are in carbon? We'll figure out what is the outer energy level for carbon. 2. How many electrons total are in the second energy level? 4. Where are they? 2 are in P and 2 are in S. How many valence electrons are in sulfur? 6. Good job. 1, 2, 3, 4, 5, 6. Yes? How many valence electrons are in iodine? 7. Good job. Why? 1, 2, 3, 4, 5, 6, 7. Why do we not worry about this? Because it is not outer. It's inner. Good job. Now, have you got the pattern? How many does everybody in this column have? 1. How many does everybody in this column have? 2.
3, 4, 5, 6, 7, 8.
Except for helium only has 2. You got it? That's valence electrons. Now, see if you really have it. Everybody in this area has how many valence electrons? Everybody. Say it, Josh.
0.
Nope. I thought I heard you say it right.
8.
Nope. 2. Who said it? Good job. 2. Everybody in this area has 2. Why? What do you say? Where do you go? Where do you go? You go out. Then what do? Come down. You go out first and then you come down. What is the outer energy level for everyone in this area? Outer energy level. 4. 4. Does that make sense? How many are there? 2. What's the outer energy level for everyone here? 5. How many are there? 2. What's the outer energy level for everybody here? 6. How many are there? 2. Now, what is the outer energy level for everybody down here? 6 and 7. Yes? So everybody in this area has how many valence electrons? 2. Does that make sense? Everybody does. Everybody does. Now, I may ask you, and you will have to know for the next thing we're going to do, which is Lewis structures next week. You're going to have to know how to find valence electrons. So that, hopefully you've got that. Pretty simple if you can count to 8. Okay? But more than that, now look at or you don't have to look, just listen. You've learned your ions. I'm being positive here. You've learned your ions. You know on the back side of that ion sheet where it says the transition metal ions, and you've got iron 2 and iron 3, and you've got 10-2 and 10-4 and all that. Do you remember all those? And then there's the question for me, why? Why do they have those charges? Why can they have more than one charge? These are obvious. +1, +2, -3, -2, -1, and no charge. Those all make sense. You've proven it to yourself why they have those charges. Why can these have varying charges? Because what happens to make them have that charge is the question you need to be answering. So let's look at that. I want you to see if you can figure out why 10 becomes 10 with a 2+ charge, and why does it become 10 with a 4+ charge. Now look at your periodic table. I'm going to write out the electron configuration notation, and you need to do the same thing all the way through for krypton. Just do that to begin with. I'll say it for you, you write. Just write it with me. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and that's krypton. Everybody with me? Do that again for the one right below it. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. That's krypton. All I'm doing is getting us up to krypton. All right, everybody with me? We're at krypton, yes or no? Energy level. It will lose electrons from an outer then if it needs to lose more, it will come inner. with that information, what does it lose to become 2 plus? Which electrons are lost to become 2 plus? Here's 10. What electrons are lost to become 2 plus? Tell me. The 2p electrons right here. Do you see that? Is p full? No. So which one's it going to lose first? It's going to lose 5p2. So to finish this up, what do you write? 4p6, here you are. Then what? 5s2, and then keep going. 4d10. Does that make sense? Do you see that? Because what have we lost? Have we lost these two? Have we just lost these two? Yes, we've just lost those two. We've lost those two. Okay? Now, how did we make 10 4 plus? We had to lose 4, right? Which 4 do we lose? We first lose these two because where are they? Unfilled outer energy level, yes. Now where are we going to lose the other 2 from? Pay attention. Do you take your jacket off first or your shirt? You take your shirt off first. Come on. What do you take off first? Outer energy level first. You're going to take your shirt off? No, you're going to take your jacket off first. Where's the jacket? 5s2. Good job, Brittany. 5s2 is the jacket. So you're going to remove 5s2, so all you have now is 4d10. That's all you will have. So make a note to yourself, lost 5p2. Make a note on this one, lost 5p2 and 5s2. Does that make sense to you? Okay? Now, real quick, I want to see if you really get it. Pay attention. Here's lead. What are the 2 logical charges for lead? Plus 2 and what? Plus 4. How do you become plus 2? Lose 6p. Yes? How do you become 4 plus? Lose 6p and 6s. Does that make sense? Now, what are the 2 logical charges? Give me my minute. What are the 2 logical charges for titanium? Now, you better pay attention. What is the outer energy level for titanium? 4. So what are the 2 logical charges? Plus 2 would be how? That one's the immediate logical. How do you become plus 2? You lose the 2 out of 4s. And then what's the other logical charge? I heard it. Plus 4, because you would also lose those 3d. Does that make sense? Does it make sense? Guys, you practice this ASAP. Practice it. You got it now, so practice it and don't forget to do your homework. I'll see you on Tuesday.